All right, folks. Sorry, we are back. I apologize. I had to go and switch over to a different video setup. I will. I hope I sent it out to all of our viewers. You guys can look at the. Hopefully, you guys can actually see the live stream right now. If there are any technical problems, please let me know, um, and we will, you know, act accordingly. Um, so, uh, I guess to reiterate some of the things, I may be repeating myself here. Today, we are covering, like I mentioned before, we had some technical difficulties. Chapter 4 of the Art of the Metaobject Protocol, which discusses protocol design, and it covers some features for extending the language in terms of adding features on top of invoking and dealing with generic functions and methods that you are overriding for those generic functions. To start things, to bring people up to speed who are just joining us, uh, hopefully folks on the live stream can step in on chat. If you guys have any questions, let me know. We're coming up with a counting example for dealing with potentially in like a performance analysis case, how many times a particular generic function and or method gets called. It turns out that there's a couple of methods that were convenient methods that were built in for closeout, but that are not unavailable. That are unavailable. We have to re-implement them for our common Lisp example here to deal with applying an actual generic function to its arguments. The normal way of dealing with applying a particular generic function includes just one second. Sorry, I'm just noticing. Can folks uh, on the call look at the stream just to see if the stream is running right now or not? Because I don't seem to know if, because I see it says end stream. I see people are watching it, but
Can you move your cursor around?
yeah.
Make it move or do something?
Sure. Give me a second.
Yeah, it's running.
Okay, cool. Okay, just want to make sure. It looked like it was paused for a second on my other desktop, so I thought I was not coming through. Sorry, today's been nothing but issues. um, but yeah, so the approach of actually dealing with applying a generic function to its method is computing applicable methods using classes. And this introduced what we were talking about before we had this real technical difficulties. The differences between what the authors call functional object-oriented protocols and procedural object-oriented protocols. Functional object-oriented protocols are, as I understand it, and this is definitely it adheres to standard principles of functional programming. You are computing things once. They are no once the function has been invoked and the result has been computed. It's cached, and that result is always returned from the function. It becomes essentially an accessor to some information at some location. This is commonly used, particularly for things that you know will never get or should never get recomputed. And these are situations like if you're computing class precedence lists, because the class precedence list should never change once it's computed once. If you're changing it using, say, things like if you're redefining the class and you end up using change class or something like that, that might invoke another recomputation, but that's a different class completely than the class that you originally dealt with when you were creating instances for. So treat those as essentially two separate invocation on two different objects themselves, because the state has fundamentally changed. The inputs have fundamentally changed. But given the same input twice, once it's computed the first time the generic function is invoked, and this includes things like what you see here, compute applicable methods using classes. Another one is compute class precedence list. Also, there's things like I don't believe finalize inheritance. I think that's actually part of the procedural protocol. But things like what was it? Slot compute slot effective slot definitions. All those are actually computed once, cached, and then left alone. They're not recomputed every time a function is invoked, because that's a lot of overhead sometimes, depending upon how deep your hierarchy could go. Procedural protocols, on the other hand, are things that are producing some part of the actual system behavior. They're performing actions. A couple of these include some examples of this is finalize inheritance, which deals with actually finalizing the allocation metrics and the what's it the now the slot access, the just making sure that the everything is kind of like in place before the instance is actually created. This uses there's a particular protocol related to finalize inheritance specifically that we'll be discussing later on, but this is part of the procedural protocol because its main responsibility is to deal with performing some sort of action to finalize the actual invocation chain. So you can see that there's a yeah. Mm-hmm.
Quick question. When I was reading, I couldn't quite understand that. I don't know if maybe if you have more clarity or Mike. But when they were specifying something as functional versus procedural,
mm-hmm.
I wasn't sure if they were excuse me, necessarily strictly referring to functional in the sense that like the thing was only definitely computed once, or more in the sense that the functional stuff provided information about something back, whereas the procedural stuff was to actually like do something. Well, it wasn't very clear if the functional thing was always meant to be assumed to only be computed once. I know they said like, sometimes some of the functional things would be memoized, but I wasn't sure if it was like always something that was assumed when it said it was functional.
I got that feeling when I was reading through the examples that he particularly presented, mainly, and the memoizability is just to enforce for one thing, Lisp doesn't have immutable variables, right? So the memoizability is one way of guaranteeing that you're always returning the results once you pass in the same inputs, right? Otherwise, you could change things underneath and people won't necessarily know. But his examples that he brought up seems to indicate that that is the case, because he specifically says the function is called to compute the result, which is then used by other parts of the system to produce the intended behavior. So it's affecting the overall behavior of the system, but it doesn't actually produce it. So it's changing the state of the system only by providing the results that it computed previously. It's not changing the state by doing some sort of transformation, some additional operations every time the function is called. At least that seems to indicate that it's a compute once, return always kind of like metric. But
yeah,
I could be wrong.
Yeah, and that's the place where I was kind of fuzzy, because that's what it sounded like. But then when he when later when he talked about the different layers, and then specifically the I forget the name of the method, the one that is like the predicate for the sort that determines if one method is more specific than another.
Mm-hmm.
That would seem like something that I don't know, you might potentially want to have act differently depending on where it's being called from. You know what I'm saying? Like, I don't know if you'd always necessarily have that return the same result depending on, like the meta classes that are involved or whatever. So,
but you're not changing necessarily those meta classes on the fly, right? You're passing in the same classes to that particular uh, function, right? It's always being invoked with the same information. I wouldn't think that in those cases that you would want to perform some sort of an action every time it gets invoked. Like, and I go back to mainly the things that that were presented as examples where you'd want to deal with it, and those are things like you're trying to enforce a particular call order, a inheritance order, a way of you want to deal with a method combination. In fact, I think somewhere earlier he mentions in the footnotes the method combination facility as being a powerful mechanism for dealing with things like the ordering in which something is done, and that seems to imply that that's like what you'd want in a more procedural sense than in a more functional sense, right?
Yeah, I agree with like the functional / procedural like distinction where he's saying that the functional thing kind of returns information, whereas the procedural thing is doing something.
Mm-hmm.
But I'm just saying that I wasn't sure if he strictly meant functional in the sense of, like I was saying with like the memoization. If something is labeled in the Metaobject protocol as a functional protocol,
mm-hmm.
does that mean that you were to assume that thing could potentially be memoized? Like, is that something that should be in the back of your head? Like, once I return this, that's basically set. Like, I always need to return the same value. Or is that, that's the thing I was kind of fuzzy on. I just wasn't sure if it strictly meant that you always had to return the same value for the same inputs.
Okay. Yeah, I see what you're saying. Yeah, I would believe that is the case, unless corrected, just because of the way they brought up the different examples of functional protocols that they believe are strictly functional. I can't think of a method where you'd want to compute the result every time based on the state, because that means you're performing and more importantly the results will change given the same inputs, in that if you claim that protocol is functional, right? That particular description that you're providing seems to indicate that what you want to do is perform some action based on some internal additional information, some additional context, given the same inputs, which would fall squarely in the procedural area rather than the functional area. But again, I don't know if other people have opinions on this. This is just based on my reading of the actual description. Does that make sense?
Yeah, thanks.
But you actually alluded to the next thing that we kind of want to talk about here, which is layered protocols. Throughout these exercises and throughout the book so far, up until this point, you may have noticed that there are a lot of the protocols that we built were essentially functions that started at a very, very low level that were very, very generic. And we built up additional protocols on top of those functions. These they're not necessarily high order functions. They're just functions that are wrapped around this functionality that you have more flexibility with. Essentially, from a design patterns perspective, I don't want to introduce this here, but it's the closest analogy that I can come up with. You could think of it kind of like how the template pattern works, where you're able to specify particular functions that are getting invoked inside of your base class that your subclasses can override just by adding the functionality in their method overrides. It's the same kind of idea. I'm not going to say that it's exactly the same, but it's the closest analogy that I can come up with. These kinds of protocols are very, very advantageous in general, and in particular for Metaobject protocols. The book actually has a very nice description here about on the advantages here. They say that protocol layering is a powerful tool for helping protocol designers meet the needs of their users. Lower level, highly focused layers provide easy handles for what we expect to be common needs, whereas higher level protocols are a fallback strategy. They may be more difficult to use, but they give the user more power. So what that means is the lower level protocols, that is the lower aspects of the machinery, those guys are give you easy hooks to actually go and hook into the object system and change what you need in order for you to accomplish your goals. Whereas with higher level protocols, while there is a learning curve because it's essentially learning an API, an opinion on how something is done. It gives you more complete power because once you understand that opinion, you'll be able to use it in a lot of different use cases. And they specifically introduced this to bring up some additional methods that are required in order to actually implement our generic function implementation of apply generic function. Sorry, there's too many generics in there, but that's how it's been written. Particularly, you have you would have compute applicable methods using classes in your protocol. Now again, these are low-level functions, and by that means that you can these are used to actually, provide some hooks into the machinery so that you could override them. There is method more specific, which is a predicate function. This function is designed to essentially be a protocol that does nothing more than determine whether the first method is more specific than the second relative to the given argument classes that are passed in. This is primarily specialized. So methods that use this may only specialize on the first argument, but the standard method that you end up using could be overridden to deal with a different hierarchy altogether. And the final method that you would need to deal with some of these extensions is apply methods. This is dealing with orchestrating the application of the methods given the arguments that are passed in. This is the actual function that does the work. And it can be overridden. This is the method that actually apply generic function uses to apply all the given methods that it consolidated for the generic function and then executes them. Now, in terms of the dichotomy that we were talking about here between functional versus procedural, the top two methods are functional in the sense that they compute results and are always there at least the way the documentation is specified. Whereas the applied methods, and you could see this makes sense because, you'll get different arguments. You could potentially get the same results for different arguments or different results for different arguments. Uh, and so the applied methods is literally just an action. It's a transformation that's going to deal with it based on the context in which it's been invoked in. So at this point, I'm going to just show you some how this can be applied to implement this applied generic function. I'm going to go ahead and delete this guy. Put this here. Boom. Okay. So now, and of course, I got to remember that this guy here in our C2 mount standard. There we go. So we now have our counting GF generic function. We have our generic applied generic function declaration. To implement this, we need to first implement a primary method for this guy. And what we could do is we can actually go ahead and standardize this on standard generic function here. And of course, you need to pass in the arguments for this guy. And we could kind of follow the same logic that the normal Lisp function approach that Closette uses it does. So we get applicable methods by computing using C2 map compute applicable methods using classes. And this is taking in our generic function and a function called, and we need to pass in the arguments. Now, what we want isn't necessarily the arguments themselves, but their types. You want their types to do the actual lookup. If you actually look at the signature here, it's actually looking for the list of classes that this generic function is looking for. The reason why you want those classes is if you recall how class works for method dispatch, it essentially does a lookup based on the order, the classes that are passed in to find the method implementation associated with that class combinations, and then will return you that method pointer. So how would we get that from the arguments? We could do map car. I think we could just do a, wait, I should have to do this, class of on the arguments, and that should be it. To get the classes for those arguments. But I might be messing up something here. I have to put a rest on this guy, don't I? To get arguments. So it's one or more. Yeah, that's right. Now that we have the arguments and we have the actual methods, we can actually do our work. We check to see if we actually have any applicable methods. That's simply a null check. Actually, do I need to even do if null? No, we don't need to do that. We could just say if applicable methods.
Ram, I don't know if you need a rest, because when applied generic functions called, I think the args are already in the list, aren't they?
I don't believe in this case they are. I don't think so, at least. Let's see. How would we use this? You might be right, but I'm not sure, to be honest. I think for the generic function signature, we may need it here. But where can I actually go look that up?
That's probably like somewhere a little bit before page 40. Because you want to see, right? You want to see what's passed into that when it's invoked. Yeah. So you want to probably just look at the original definition of applied generic function.
Ah, yes. You're talking about the use is going to be applied generic function list door. Okay, you're right. This is going to be... okay, let's go this. All right. So then we do if applicable methods. Oh, I see what they're doing. They're throwing a null check here for the purposes of throwing up an error, saying that we have no applicable methods, so that we hook into the debugger. Okay, so we do this. We throw an error to see if there are no applicable methods for this generic function. For the this is just grabbing the I think it's just this indentation. This is just a format string. Give me a second here. Function s and when arguments and then we just pass in the generic function and the arguments otherwise. And if we don't have that, then we can call c2mop apply methods. Seriously? Apply methods should be available. Let me just make sure that I'm not going crazy here. I thought apply method is part of the mop. Allocate instance. Is part of the mop. Independent. Attributes once I compute them, apply method should be just a fun call on the list of stuff, but I don't think that that's the only thing we can do. On the arguments. Let's see what goes here. Let's make sure I get this on. Go look up something here. This is back in chapter 2. Let me just look at where is apply methods? Here we go. Apply methods calls apply method, but apply method is Here we go. Here we go. Yeah, we're gonna have to go and implement the apply methods thing too. Okay, we'll do that. That's fine. Those are all generic functions. Okay, and then we just do apply args applicable methods. So now that we have this, we can compile this, make sure there are no errors. Of course, it's going to warn that there is no applicable method, blah, 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 blah. Attempt to add standard method to the generic method, but the method has more required arguments than the generic function. What? There we go. Sorry, earlier when I changed the function signature, it looks like it didn't, I forgot to compile it. Yeah, this warning for folks who are looking into this call, the warning is there because the applied method doesn't exist currently. I'm going to pause for a minute to see if there are any questions through our YouTube channel. Give me a second. Videos. Are there any? Huh. Sorry, I have to go look at something here. My apologies. I'm just looking up. See, the live stream link is not showing up on the page. That's why. Public. All right. Now that's better. Okay. All right. Let's see here. Okay, so now that we have applied generic functions, of course you see there's a before method for this. Clearly this is going to increment the call count before we need to do that. We need to implement the override for method more specific, if I'm not mistaken. Def method C2mop method there is no, yeah, so we're going to have to write a generic function called method more specific. More specific for our two methods. Someone have a question? No, that's probably yes. The required classes. This is nothing more than, as I mentioned, it just checks to see, given two methods, which one is more specific given the required classes. That's usually what you do when you look up the class precedence list for a given class, and then you just figure out based on the class precedence list uh, which one is the more generic method based on the order in the class precedence list. We will implement this for standard methods, but and I could go on this, but this is something that I'm going to leave to an exercise for you guys. I'm going to post this code up just to see what you guys come up with, primarily because some of this is available in the book in terms of implementations, but and I'd rather have us to see some interesting solutions from folks being posted. The final topic on this is a section called is on performance. This is a pretty important topic to be aware of because when designing object-oriented programming languages and meta-object protocols on top of object-oriented programming, especially, you have to be aware that the facilities for optimizing generic function invocation are impaired by this generic function invocation protocol. There's obviously been techniques and research done on this for years. SBCL has probably one of the better, implementations of this, as far as I know. But it is something to be aware of that if you go well into the Metaobject protocol land using the generic function invocation overrides, optimization could become somewhat of an issue, and this is if you especially design your own Lisps that has this functionality. The book mentions a couple of things related to how it dealt with it in terms of adding features for efficient method invocations. Two particular methods that it mentioned for Closette, I don't know if they are available in the MOP spec, which we'll be covering next week, are compute effective method definitions and what's the other one? It was compute discriminating functions. Those two are primary. So compute effective method definitions are kind of like how we did compute effective slot definitions, in that it figures out the call chain for a given method call and creates a new. Essentially, I think it was just a lambda that combines them up and then returns that lambda for you to invoke every time. So you don't have to recompute the method call chain every time you invoke a particular method, because that computation has been done once. This is another application of the functional protocol kind of design pattern that was brought up earlier, that we were talking about, that dichotomy between functional and procedural. The other thing is compute discriminating definition, which basically deals with functions that transform a procedural protocol into a functional protocol where it returns a function which itself can be called whenever the generic function is invoked. So it's kind of a wrapper function. The main reason why you use these kinds of functions is to discriminate on the arguments to figure out which methods in your combination you'd want to apply. And compute discriminating function handles that implementation. Again, these two protocols functions in the API that I just mentioned. Don't believe they're closed at specific, but I can't say for certain because I have not actually. Compute effective method is available instead of compute effective. What was it called? It's compute effective method function. Yeah, compute effective method function. It's kind of the same idea. It has compute effective method, but compute discriminating function is available in the MOP spec. Again, I'm mentioning a lot of these things that are in the MOP spec because while you can certainly take the first 4 chapters of part 1 in this book and go off and design your own Metaobject protocols, we're in Common Lisp. Let's try and use what's available there. You can certainly write your own Metaobject protocol for Common Lisp as well. I won't discourage that because it'll be an interesting design space to certainly try out things. But at the same time, be aware that there is a standard one, and if you're writing applications, leveraging it would be pretty useful. Let's see, is there anything else I wanted to talk about? Any topics of discussion from the general audience? Michael Gargano, did you have any other confusing points that you went through when you went through this chapter?
No, not that I can think of specifically right now. I mean, I always have a million questions about everything.
Yeah, of course. That's a real.
Nothing I can think of at the moment.
Okay. Before I let you guys go, I do want to mention that it's getting around that time again for the Lisp Game Jam coming up. It's about a month away, I think. No, 2 months away. I'm going to mention it, and I'm hoping that, and I encourage folks that are watching to come up with topics that they want to see in relation to some stuff that you might want to do for the Game Jam, and post them on Mattermost. I'd like to get a series of topics going related to some of the interesting things for game programming, and start presenting some of them even while we're going through the MOP. Maybe even try a couple of things to see if we can go through the MOP. Other discussions, folks who are in the Atlanta area, I don't want to forget, and I don't want you guys to forget, that we are looking for speakers. Please contact either me or Judd Taylor via meetup.com and to give us your talk topics so we could schedule something. Folks who are on the Lisp study group, topics are welcome. Also, general topics in addition to the game programming topics I've mentioned earlier. Please post them on the Mattermost channel, CL Study Group, or on Discord and functionalprogramming.slack, and I will certainly get to them and put them on our list of topics to discuss. So until next week, I think for the next couple of weeks, if there are no other burning topics coming in, we may want to really dig into the MOP specification itself. It's really an API documentation. If you read Chapter 5 and Chapter 6, a lot of information in there. I'm trying to think of some examples of going through myself to see how we can apply some of them and see what we could come up with. Folks who have ideas related to that to apply the MOP, feel free to post on Mattermost as well, and we can see if we can get those into as well. But if there aren't any other questions, I will see you guys next week. Sorry for folks who are coming in late. I apologize for the technical difficulties. Hopefully, moving on, we can forward starting next week. We can resolve some of these. Maybe go back to Hangouts for a bit, and then once we figure out the Jitsi problems, we may revisit that and announce it on the chat forums.
So the game jam will probably be. I wanted to say something about that really quick.
Okay, go ahead.
The game jam is usually the second Friday of April, so that puts it at the 10th. So it's going to be a little earlier this year.
Okay.
For like 2 or 3 weeks before that, I would like to demo some libraries that are available that people may not already know of, because the game jam brings in a lot of Lisp newbies and even experienced Lispers that haven't dived into the game dev space yet. So I kind of wanted to demo what's available and just to make it widely known what's available for making games in Lisp. So probably like March 27th, April 3rd, and the day and no wait, we're on a Saturday, not a Friday. So that would be March 28th, April 4th, and April 11th.
Okay.
Day after the game jam, because most people start on the weekend anyway.
All right.
I just wanted to demo some things. I might even show off my own creation that hasn't seen the light of day yet.
Oh man, I'd be excited for that too. Yeah. Then you heard it, folks. March 27th, April 4th, and April 11th. We have a game programming series on interesting game libraries in Common Lisp to write video games. Stay tuned. We will get those scheduled, and we'll keep moving forward.
All right. Have a good day.
See you guys later.
Bye.
Bye.